Hi everyone. In this video, let us discuss about the problem longest common subsequence. Given two sequence text1 and text2, return the length of their longest common subsequence. If there is no subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. So you can see the subsequence nothing but first we should follow left to right, and it should follow that relative order, and you can delete any elements in between. So common sequence of two strings is a subsequence that is common to both strings. So you can see example ABCDE and ACE. Here the longest common sequence subsequence is ACE. So here A and C and E, so this is subsequence in this text, and here ACE same thing is a subsequence, and this is the longest common subsequence. Similarly, ABC both are same, so longest common subsequence is ABC, and text 1 is ABC and text 2 is DEF. You can see if you A is not there, B is not there, C is not there. Similarly for text 2 in the text 1 also is same, so there is no such common subsequence, so the result is 0. Now let us try to understand like what is subsequence. Already we discussed a subsequence is a sequence you can form from a string by removing some characters, possibly none, without changing the order of the remaining characters. Suppose take an examples. Let us take A B C D E. AC is a subsequence. We removed B and D, and AC are still in the order. So from left to right, you can see the order. BD is a subsequence. B and D removed ACE, so BD is a subsequence. But ED, you can say ED letters are there, but it's not subsequence because E comes after D. And also one more thing here, subsequence is not means substring. Characters must be contiguous together for the substring. So ABC in the ABCDE is a substring, but ACE in the ABCD is not a substring. But subsequence characters can be spread out as long they are in the order. So ACE in the ABCDE. And for this method the brute force will be more exhaustive, and we use dynamic programming because this problem has overlapping subproblems. Same subproblems are solved multiple times, and we have optimal substructure. Solution to big problem depends on solutions to smaller subproblems. So now let us take this example ABCDE and AC two text, and let's try to apply this DP algorithm. So now you can see I just took ACE, the string, and ABCDE. Now just let us try to solve it by bottom up approach. So let's first let's consider like a base condition. Here let's start. Here it is nothing but an empty string, and the same here it is nothing but like a empty string. So we just adding each letter. If you go from bottom to top, it is empty string, and this is we added A, and it is AB, and up to here ABC, and it up to here ABCD, and up to here ABCDE. Similarly here also, first let's try to understand like it's a empty string first, and we added like A and C, and up to here ACA. So when this box will represent comparing just this A and A, this box will represents comparing AC and A. Suppose if you take this box, it just represents A B C D comparing with the AC. What is the longest common subsequence? And at the last, the ultimate box, this will compare ACE string and ABCDE full two strings. So this is the ultimate answer. So let's start from like beginning. So at beginning, suppose if all the here if it is complete string is empty, there is no common, so it is like a zero. So that's why what I did, just whenever the starting itself, I'm just putting like 0 0. Suppose here the empty string nothing common, 0 0 0, and vice versa also, that's why 0 0. Now let's start from here. Now you can see a and a is matching. So here we have like two conditions. One thing is, if it is matching, just exclude both of them, and just if you just remove both of them, what is the matching previously? So that is 0. So here matching, so that is a 0 plus 1. So similarly, you can go now here. So here, a and c both are not matching. When it is not matching, then just try to exclude any one of them and take the maximum value. So if you just remove a, uh, if you just remove a, that is the previous value you need to check, that is ac with comparing empty string, that is 0. Or you just remove c, that is a compared with a, that is 1. So the best out of these two is maximum value is 1. So this is the algorithm. We'll write first, if j equals to 0 or I equals 0, we'll first initialize that 2D matrix with 0 0, and then here in the I comma j, whenever it is both match, then we will cross check this diagonal value plus 1. If it is not match, we'll take this diagonal, the maximum value mat dot max of this any of these two maximum. So let's try to continue this code. So if you see a and e is not matching, so simply take any of any math or max of any of these two, because what it means, like when a is not matching e, suppose if you remove a, that is empty string with ac, what is the maximum value? That is 0. If you remove e and ac comparing with a, what is the maximum value? That is 1. So either this one or this one, we need a longest common, longest, that's why I'm just taking the maximum value of this two. So now let's now come here. Here we are now comparing ab with the a. So you can see ab, the common, the longest subsequence is a only, but it is a. But the thing is, you need to check the algorithm. The algorithm what we are writing is, if these two characters are not equal, so either you just exclude this one or exclude this one. So among these, what is the highest value? That is 1. And similarly, b and c not common, take highest, that is 1. Now b and e not common, take the highest value, the max of this diagonal is 1. Now c and same thing, c and e not matching, so take 1, that is a math dot max. Now cnc is matching, so cnc matching, so what you think? So when it is matching, try to understand, suppose if you are not taking both, you're not taking c and not taking excluding c, and here c both, then it will point to here, like it will just check where, what is the up to before, what is the longest common sequence, that is a comparing with ab, that is 1. So it is matching, so the number is 1 plus 1, that is here we have 2. So whenever it is matching, we take this diagonal plus 1, or if it is suppose c and e is not matching, we can take whatever maximum of these two, that is a 2. And similarly, d with a, that is not matching and taking 1, and here d with c not matching, I'm taking 2, and d with e not matching, I'm taking this maximum of 2, and e with a, that is not matching, I'm taking 1, then e with the c not matching, but here the diagonal is 2, so I'm taking 2. At the last, e is matching e, so that's what I said, when it's matching, you should take this diagonal, this opposite diagonal, and 2 plus 1, that is 3. So yeah, this is the answer. Maximum, so you can, if you can keep increase the characters here, you can keep increase the character here, because it has the common sub problems that we are starting from the base. This is the base, and we are keep increasing the that towards a larger problem, and we are doing it. So 3 is the longest common subsequence. Why? Because ace is easier and ace is here. So this is how algorithm is working. You can check the algorithm is same. I wrote here, if I equals to 0, I is less than n, I plus plus, j equals 0, j is less than or equal to m, j plus plus. I just constructed 2D matrix dp, 2D, we can say 2D dp. So then your whenever I 0 or j 0, I'm initializing with 0, because you can see first 0 0, and then when text1 dot character of I minus 1 is equal to text2 dot character of j minus 1. So if it is both are equal, what I am taking, then this diagonal, suppose here both are equal, so this diagonal I minus 1 j minus this diagonal plus 1, so I'm taking this diagonal plus 1. If it is not matching, then just take math dot max of either this one or this one, so I minus 1 j or I j minus 1 math dot max of thing. And at the last I'm returning the end dp. This cell will represent abcde and ace, the longest common subsequence. So this is what we discussed here. So we can see we are using dynamic programming because this problem has overlapping subproblems. Same subproblems are solved multiple times, and we have optimal substructure solution to big problems depends on solution to smaller subproblems. So I'm running this code, and this is code very easy but more tricky.